So hi guys, welcome to my channel. So today I'll be solving this GFG problem of the day, which is longest prefix suffix. Difficulty is marked hard, but it's like very easy when I'll be explaining you the approach, how to approach this and the intuition behind this. So let's read the problem and try to approach this. So you are given a string of characters. You have to find the length of the longest proper prefix, which is also a proper suffix. Okay. Prefix and suffix can be overlapping, but they should not be equal to the entire string. Okay, so the first test case is AB and AB. So what is the longest prefix and longest suffix for this? Okay, so let's first see that what is prefix and suffix. Okay, and I want to clear some of the things before like finding the longest prefix and suffix. Okay, so prefix is this part, the leftmost string. Okay, prefix, and this suffix is this part, this is the rightmost string. Okay, so while I say the longest prefix and suffix which is matching, let's say this is A, B and C, and this is C, B and A. You see that you'll say that okay, CBA is matching. No, if I say longest prefix and suffix, then it should not be CBA. I remove this A, B and C. Okay, so this is known as the longest prefix and suffix which is matching, or I'll say that the string P and string C with string S which is equal. Okay, if I add this D, then D shouldn't be added here. Okay, no, D should be added here so that ABCD and ABCD should matches. Okay, so I hope the longest prefix and suffix is clear. Now let's find it in the string. Okay, so you all can see that, is this matching A, B? No, this is not matching. Okay, let's see, is this matching AB, AB? So we can clearly see that AB is equals to AB, means the longest prefix and suffix for this string is 2. Okay, so 2. Now let's take another test case, A and A. Okay, so let's write it A and A. Okay, so what is the longest prefix and suffix for this? Okay, so let's see A. Now what I have said, that prefix, longest prefix which is equal to the suffix. So okay, this A, okay, so this A is matching with this A. Okay, so length is equals to 1. Okay, so let's now move further. This A is also matching with this A. Okay, length will be equal to 2. Now this A, this part is also matching with this part. Okay, so length is 3. Now I can say that this part is also matching with this part. Okay, so the length is equal to 4, but here the catch lies. You can read the note that prefix and suffix can be overlapping, means if I write this A and A, means this will be okay, can be overlapping, means length is equals to 3, but they should not be equal to the entire string. Means here the length, if I take the length of 4, then prefix size is 4 and suffix size is 4, and the length of the string is also 4, so we cannot take this. Okay, so I hope this is also clear. So the two things which I have explained you, first is the longest prefix and suffix, how many characters we can take, and the overlapping concept. Now we have to find the length of the longest proper prefix which is also a proper suffix. What is the meaning of proper? Means if I say the longest prefix and suffix and longest proper prefix and suffix, means let's say we are given a string this. Okay, let's say in middle of this we got AB, and we got here also we got AB, so its length is 2. No, we don't need to return this. So longest proper prefix and longest proper suffix means the characters of prefix will start from this size, okay, and go up till any other size. Okay, proper suffix means the character will end at the end, like end of the string. Okay, the ending character of the suffix should meet the ending of the string. Okay, this is the proper suffix. Okay, we cannot take any of the middle part and match that. Okay, this is the proper prefix and this is the suffix. No, we have to take the characters in the prefix string which is starting from the beginning and go up till anywhere, but should not end at the end. Okay, so we will, whatever characters we will be including in the prefix should start from the beginning of the string. Okay, and go up till anywhere until and unless it reaches the size -1 or -2 means it cannot, like, overlapping. In the overlapping condition, we have been told that we cannot take the entire string, so we can take up till here. Okay, and if we are including the suffix part, so whatever strings we are taking should end at the ending of the string. Okay, again I'm repeating, whatever string we are including or characters we are including in suffix should end at the ending of the string. Okay, so I hope this is clear. Now let's see how we can find this. So its answer is 3. Okay, so its answer is 3, not 4. Why not 4? I have explained it. Okay, so this is the test case, and let's first find that what is the longest prefix and suffix for this. So let's make a LPS array, LPS longest prefix and suffix array, where we'll be storing that what is the longest prefix and suffix we get till that particular index. Okay, so let's start iterating. Okay, when I am standing at 0th index, what is the maximum, like, or what is the longest prefix and suffix I can get till 0th index? So a we can see that from left side we can take a, from right side we can take a, but it is given that we cannot take the characters which is equal to the given string. If we are taking this string only, this particular string, so prefix cannot be equal to the size of the string. Okay, so our first answer will be 0, like till 0th index there is no prefix and suffix which is matching. Let's move to this index 1 till 1. Okay, so we can take this index a and a, it's matching. Okay, so the size is 1. Okay, again we cannot take this a whole and a whole because the prefix cannot be equal to the size of the string. Like till here, if we are considering this string, so a cannot be taken as the prefix. Now let's move to second index. Okay, so a and a, so we can take this a, we can take this a, so its size is 2. Okay, so its size is 2. Now let's move to 3. Okay, so if we are at third index, so what is the character we can see? Okay, so at third index c and a, it's not matching, so we cannot consider this. Okay, so its size will be 0. Longest prefix and suffix till here is 0. Now fourth. Okay, so what is the longest prefix and suffix? We can take this a, we can take this a. Okay, so a and a, which is equal to size equal to 1. Now let's move to 5. Okay, so a, okay, we can take a matching, then again a matching. Okay, then a, and here ca not matching, so the size will be equal to 2. Now let's move to another index which is 6. Okay, so here we can see that triple a is matching and triple a is matching, but the c is like not getting in any of the things, so we cannot take c. We can see here is a and a, here also a and a, so it's matching. If I take a c, so c a, it's not matching. Okay, so the size is equal to 3. Now coming to this index, 7th index. Okay, so you can see that these three characters are matching and these three characters are matching. So if I extend to size 4, then a, and size here also 4, then a, so it's not matching, so the size will be 3. Okay, so let's maintain one length variable. Starting okay, so let's start iterating. Okay, so if we are standing at 0, our length is 0. Okay, our length is 0. Okay, and our LPS is also 0, because if we are standing at first character, we are taking the string till this, so prefix cannot be equal to the entire string length. Okay, so at starting we'll be putting 0 to our 0th index. Now okay, so we are standing at first index. Now we have to match that if its a is matching with length. Okay, length 0 means we go to 0th index and match that whether string of 0 is matching with the string of I, means string of length is matching with string of I. Okay, it's matching means a and a is matching, so we can say that we can take the answer as length, like we get the longest prefix and suffix of length 1. Now let's move to this index and let's move increase the length variable to 1. For index 2, what we have to see, like we have got, okay, so we have get this index and this index as longest prefix and suffix. So we have to check that, okay, we have got the length 1, means till here we got the matching index, till here we got the matching index, whether we will be able to extend it to this one length. Okay, so we have to check that whether 2 which we are standing on is matching with the next character of the string length which we have already calculated, means we already got this a matched with this, whether we can extend to this first index. Okay, so if this a is matching with next to this, means the string of length means 1. Okay, a and a is matching, so we can extend to this, a is matching, a is matching, so it will be equal to 2. Let's increase the length variable. Now let's move to next index. We are standing on 3. Okay, so now we are standing at third index. So this is the very important part of this video, means this is the like deciding factor of like how we are calculating this, what is the approach of this. So listen it very carefully. Means if we are standing at third index, so we got the, currently we have the length of 2 which is matched already. So we got this a matched and this a of length 2 matched, means the prefix is of size 2 and the suffix is also of size 2. Okay, so let me write the prefix we got till here and the suffix we got till here. So if we want to increase it, increase the range, so what we have to do this. Okay, so we got a here and a here. So if we want to increase this, so what we have to do this, whatever character we are getting here, we have to match it with this index. Okay, so whether it is possible to extend the size. Okay, so till now we got the string till here and till now we got the string till here matched. If we want to, if we are standing at third index and if we want to extend the size of 2, length 2, then what we have to do, again this I'm repeating, what we have to do is we have to match the character present at third index with the length plus 1, means till length 2 size we already got and the size index is of 0 1 2, so we have to match it with second index. If it is equal, then we can extend our length. Okay, so let's see, the third character means C and the length means str of length 2 is C and A matching? No, it's not matching. So what we'll be doing? Okay, so we failed at 2, means till here we failed to get the length of prefix and suffix of size 2. So what we'll be doing? We'll go length minus 1, which is 1. So we'll be reducing length, means reducing it to 1. So let's find that whether it is possible to find the prefix and suffix till third index of size 1. Okay, so now what we'll be doing? Okay, so we failed at matching this index, still standing at third index. We are still standing at third index. So now let's remove a we already got for size 2. If we want to increase it to 3, we failed it. Now what we have to do, okay, so now we have failed to get the length of 2 which we are going to extend it to 3. We have failed. Okay, so let's remove this a and remove this a. Now we have length of 1. Now our task is to whether we can increase the length of 1 to 2. We can check. So now what we have to check, if like currently we have got a length of 1 which is matching. Now if we want to include this character, we have to check it with the next character of the current length, that whether it is matching with this or not. Okay, so now what we are doing, length of like str of 3 which we are currently standing on should be matching with the str of length means 1. Str of currently standing should be equal to the str of length, because this a matching, so we want that C should be included to this and this should be included to this and it should get matched. So let's check, C and A is not matching. Okay, it's still not matching, so we'll be reducing it to 0, means coming back to this. So 0 size. Now let's see that, let's check. Okay, so let me remove a also. Now we have, what we have to see, whether this character is the beginning, like this character is the starting. So we have to check for 0th index, that whether the character which you are currently standing on, it's matching with 0th index or not. Means length or not. So what we are doing, we have to check it with C is equal to A or not. C is not equal to A means simply we cannot reduce the length to -1. So what we are doing, simply put 0 here and move the index to further. Okay, so now let's move. If we are standing on A4 means we previously what length we have got, 0, means we have to starting from 0, str of length. Now we have to check that str of whatever index we are currently standing on, whether it is matching with length of 0 means 0 or not. So A and A is matching. So what we are going to do is we have to increase the, like we got a length of 1 matching and 1. We can clearly see that if we take till this index A, C and A, what is the longest prefix and longest suffix till this index? Okay, so we can see that this we can extend it to A, we can extend it to A. If we are going to further extend AA, then AC, it is the red flag, so we cannot extend it. So I hope this is clear. Now if we are moving it to 5th index, so now we have to check that whether we can include. Now let's see. Okay, so till 4th index we got A and A matched. Now if we want to include the 5th index, then what we have to do, this index should get matched with the next index of the length, means one length A. So whatever character present after one length means this means 0 or 1, it should be matched with the 5th index, then only we can extend our length to 2. So we have to check the correct index which we are standing on, means 5th index should match with the length. We can say that this can be taken as the index. So is str of 5 is equal to str of length. Okay, so str of 5, which is 5, is equal to str of length. Okay, we got 1. Okay, matching. So we can say that here also A is present, here also A is present, means we can extend the length. Okay, so let me extend the length to, it is 2. Okay, so now let's move to 6th index. Okay, so if we are standing at 6th index, so again we have to check. Okay, so we have this, now we are standing at 6th index. Okay, this is 5, this is 4. Now if we want to include, let me write this is fixed, let me write this is also fixed. Now if we want to include the 6th index, then what I'll be doing, I have to check the next index of the size, like 2 size we already got as a prefix, 2 size we already got as a suffix. If we want to include the 6th index, then I have to check for the next character of this like size. So it is equal to 2, index 2. So if 6th index is matching with the index of 2 of str, so then we can extend it. So we can check index of 6 is A, index of 2 is A. Okay, so we got A, so we can write here also A is present, here also A is present, so we can extend it. So we can extend it to this. Now what we'll be doing, we'll increase the length to 3 and put 3 here. Okay, so next condition. Okay, so if we are standing at 7th index, now okay, this is fixed, this become A, this is fixed, this become A. Let me remove this, let me write 7. Okay, so whatever index we got in 7, is this matching to the next character of this 2? Whatever index in 7, is this matching to the next character of this size, which is 3 we have taken. So this character, this should match, then only we can extend it. Okay, so this is 3. So let's check whatever character is in 7, is it matching with length of 3, means str of length, it is 3, this matched, this matched. Now we have to include this and this. So C and A is not matching. Okay, so if it is not matching, then what we'll be doing, we'll reduce the length to 2, means we'll be going back. Okay, so now what we'll be doing, we'll remove this and we'll remove this. Now we have to check for size of 2. Okay, just remove this has not matched. Now remove this. Okay, so if we want to include the 7th index, then what we'll be checking, okay, I have to reduce the, okay, so what we'll be checking, the next index of the size, means length of 2 we already got. Now we have to check for this index, whether 7th index can be can matched with this prefix, whatever length we got in the prefix, the next character of this prefix, which is this. So it is 2. Okay, so we have to check that str of wherever we are currently standing on, means 7, is it matching with the length of 2, means index of 2, because we got already length of 2, so this character. So 7 character is matching with this. Okay, so we can write here 2, index of 2 is a, now index of 7 is also a, then we can extend our length. Okay, so we have extended our length, this and this. Okay, so we have to extend our length to 3 and finally writing 3. So we have very clearly find the LPS, like longest prefix and suffix. Okay, so now this is how we have calculated the LPS of like longest prefix and suffix for each index. Now let me tell you one thing, that what is LPS of I depicting? It is explaining that what is the longest prefix and suffix till the ith index. Means if we have to calculate till this, means LPS of 0 explaining that what is the longest prefix and suffix till the 0th index. Means if we take only a, then what is the longest prefix and suffix, which is equal to 0. Now what is LPS of 4 depicting? It is saying that what is the longest prefix and suffix if we want to take a, C and a. So it is 1, because we can see that we can extend it up to here and here. Okay, so now what is LPS of 7 like explaining? It is saying that what is the longest prefix we can take if we take the entire string, and it is equal to 3. We can see that we can extend up to here and we can extend up to here, because here C is coming, here is coming, we cannot extend. So finally we'll be returning 3. Okay, so now what are the steps we are following in this? Okay, so this is the smallest code of this LPS. Okay, so if at the starting of LPS, while we declare the longest prefix and suffix vector, we'll be marking it as 0. Why? I have explained you above, because if we want to take this only a, so prefix of this and suffix of this cannot be equal to the size of the current string. So at starting equal to 0. Now I'll be checking that whatever index I am currently standing on, whether it is equal to the length of string or not. Means index means I have explained you that if I want to check this, so if length is 2, then I'll be checking at second index that whether it is matching it with this or not. If it matches, then I'll be increasing the length, means we can extend. Now LPS of I, mark it to length, now doing I plus plus. Okay, because we have to move to next index, we'll be increasing this, now this. Okay, so what if it doesn't match, like this case fails, then what we'll be doing? Then our new length will be equal to, okay, so if we fail in matching with this, if we fail, then what we'll be doing? Let's say in this case we have failed, then what we'll be doing? We go to length minus 1. What is the previous length we got? Okay, so LPS is equals to like length is equals to LPS of length minus 1. Means if we are standing at 2, then we'll be checking at what is the LPS of 1, means what is the maximum or longest prefix and suffix we get at length minus 1 index, which is stored in LPS. But it will be only possible if length is not equal to 0. If length is equal to 0, then 0 minus 1 will be equal to negative. If it is negative, then we don't have to do anything. Means if length is not equal to 0, then our new length will be LPS of length minus 1. What if length equal to 0? If length equal to 0, then simply we can say that LPS of I equal to 0 and move the current index. Why? Because we can say in this case we have reached till this index, 0th index, our length will be equal to 0, and now we are comparing with this and 0th string a, it's still not matching, then we have marked it to 0 and moved to next index. So this is how we are calculating. So our time complexity for this problem is big of n, like let me write it. Time complexity for this problem is big O of n, and space complexity of this problem is also big O of n, because we are using the like LPS of this vector of size n. So space complexity is big of n and time complexity is also big of n. One more thing I would like to tell you, that this is the subset problem of KMP algorithm, string matching algorithm, this longest prefix suffix. One more step I'll be explaining in another video, and you all will be able to do the KMP algorithm, so that will be for another video. So let me show you the code, how we are coding. Okay, so now what I have told you, we have initialized a vector of LPS. That's because our space complexity will be equal to big of n, like, or the big of string. You can see that the expected space complexity. Now at starting our length will be equal to 0 and LPS of 0 equal to 0. Same as here, you can see that whatever steps I have written. Okay, so let me remove this. Okay, at start LPS of 0 equal to 0, I have explained it. Okay, so now I am looping it from index 1, because for 0th index we have already marked LPS of 0 as 0. Now till str of size, I am not incrementing the ith index here, because I have to like find I'm not sure that move the ith index or not when I'll be moving the or incrementing the ith index. So if str of I double equal to str of length means current index which we are standing on is equal to str of length, then we'll be doing plus. Okay, then I'll be doing length plus plus, and LPS of I equal to length and moving our ith index. What I'm doing, length plus plus, LPS of I equal to length and I plus plus. Okay, if the current character of the string does not match with the length, what I'll be doing, I'll be reducing the length. But before reducing the length, I'll be checking that whether length is not equal to 0. If length is equal to 0, then I cannot decrement the length. So if only length is not equal to 0 means length is greater than 0, then only I can decrement the length and set the new length. What if length equal to 0? If length equal to 0, then it comes to else statement, and LPS of I means the current index which you are standing on, it will mark it as 0 and move to next index to explore. Finally, I'll be returning the LPS of string.size minus 1. Now what is string.size minus 1? Because LPS of 7 will be storing that what is the longest prefix and suffix till this index, 7th index. So I'll be returning this, means finally our answer stored in 3. So let's run this AAC and 4A custom output. Okay, so let me write this AAAC AAAA. So your output, let's see what is the output. Okay, so we can see that the output is 3. So let's submit it. Okay, so it got passed. So this is how we are solving this problem. So thank you for watching and having patience. So thank you.